7.4 is applications. Like we saw in 7.3, it was just one-step type setups, where it's just really one operation that we're using, whether it was multiplication, division, addition, or subtraction. Now we're going to look at multi-step applications, which may include two or more of the four basic operations. Of course, we'll see these set up with parentheses, although it's not necessarily required that you use parentheses to solve these types of problems. So here's our order of operations. Once again, parentheses, exponents. This is all in order, by the way. Parentheses, exponents. Then multiplication or division from left to right. So I just can't say this enough, but division sometimes comes first because it happens in order from left to right. Sometimes it comes before multiplication. And likewise with addition or subtraction, there is part 4. Sometimes subtraction comes before addition because it happens first if we scan the problem from left to right. Now, again, it's not always PEMDAS, but when we set up problems, especially since these are applications, they're word problems, sometimes it's more intuitive just to do this part by part, whereas the order of operations kind of forces us to do that if the problem's already been set up. So if you see this and think, well, I'm already doing it little by little, that's good, because that's what the order of operations would essentially have forced you to do anyways. Suppose that each semester at a particular community college, Jared has to pay $1,673 in tuition and $80 in fees. If Jared has 3 semesters remaining, find the total amount he will need for tuition and fees. So, like I said, there's different ways to do this, and usually intuitively, you just kind of do it by the order of operations without actually having to set up the full problem. And since we saw on the assignment, at least last time I checked, that there's no need to write the translation for this, all we really want is the answer. It's not going to matter how you do it, but you should get the same answer either way, right? So for this one, we see, just looking at the costs. Now, when I look at cost here, I'm looking at cost per semester. Well, why am I looking at the cost per semester? Because it said specifically that Jared has 3 semesters. So whatever I find for the cost of the semester, I'm going to have to multiply that by, well, 3 semesters. Okay? Semesters. There we go. So the cost per semester is this $1,673. And that is tuition. But in addition to tuition, he also has to pay his fees of $80 there. So we're going to add that 80 to the 1,673. Now, I said that usually intuitively this kind of happens where students are like, well, look, I can add the 1,673 to the 80 right now and figure out what that is. And that's true, you can. Just add those two right now, because again, we're not needing to translate this for the assignment. Looks like that'd be $1,753. So that's per semester. Jared's paying $1,753 after fees and tuition, but we're gonna have to multiply this by 3. So what I'm showing here on the kind of the top is what the expression would look like if you set it up or would need to translate it. 3 with parentheses. And why do we need parentheses here? Because we would need to figure out the cost per semester first. And parentheses force us to do things first, just by the order of operations, right? Well, after adding those through the order of operations, you'd get the 1,753 multiplied by 3. And whether you set this up this way or not, you'll eventually have to do it one way or the other. So that's why that's how you're going to get your answer. So let's go ahead and multiply those two at the end. 3 times 1,753. Let's go ahead and set that up. 1,753. I'll stack it. Multiplied by 3. It's not my best 3, but it works. And let's go and multiply these. So 3 times 3 in the ones place value is 9. 3 times 5 in the tens place value, that'd be 15. So carry the 1. 3 times 7 is 21, but add the 1 there makes it 22. Carry the 2 from the 20. 3 times 1 is 3. Add the 2 is 5. So Looks like Jared, for the remaining 3 semesters he has, will need to pay $5,259 total. Ken wants to put carpet on his living room floor, I guess. The dimensions of his rectangular room are 11 feet by 15 feet. Each square foot of carpet costs $9. How much money does he need to spend for the carpet? Actually, let's take 1 minute, try this one out, and then we'll come back and do it as a class, all right? So the first thing I notice on this one is that it's looking for the cost. How much money does he need to spend, and how much is it going to cost is based on each square foot. Now I'm looking at square foot specifically because the dimensions of the room were given in feet individually, which means of course it's rectangular, so it's nice because we're going to look at finding the area of this rectangular room, which is 11. Use the marker on this one, 11 times the 15. Okay, so I got 11 times 15. This will tell me the square footage of the room right here. So let's figure this out. 11 times 15. I'll have to stack this one, at least for me. I don't know if you have to. So 5 times 1 is 5. 5 times 1 is 5 there. Now in the tens place value, 1 times 1, 1 times 1. Let's add these together to find our product. 5 plus 0 is 5. 5 plus 1 is 6. And then 1. There's 165. So there's 165. This is how many square feet are in the room. But it says here that it's $9 for every square foot. So it's like saying you got 165 groups of 9. So that's 165 times 9. Whatever we get from this, that will tell us the cost. So let's go ahead and stack this up. I'll just do the work over here again. 165 times 9. So 9 times 5 is 45, carry the 4. 9 times 6 is 54, but add the 4 there makes that 58, carry the 5. 9 times 1 is 9, but add the 5 makes that 14. So it looks like the cost for this one room will be $1,485. And yes, this is a word problem. So make sure that you're labeling your answers on these. Catherine has a garden with dimensions 17 feet by 18 feet. She wants to put a brick border around the garden. Each foot of brick border costs $7. How much money does she need to pay for the entire brick border? So this is a perimeter problem now, not a area problem. And all they tell us here is that each foot of brick border costs $7. So we're going to just figure out the perimeter here and just multiply it by that $7. How are we going to find the perimeter? Well, they gave us length and width up here at 17 feet and 18 feet. So we're going to need to take those values, 17 feet and 18 feet, and add those together. Now, of course, if I just add these two directly, that's 2 of the sides. I personally prefer to add these again a second time like this, although some students prefer to just take this, put it in parentheses, and multiply it by 2, which works as well. It's double the value of the 17 and the 18 together. I like to see all 4 values, so I set it up like this with all 4 values being shown. But again, it's really up to you. So this will tell us the perimeter of this garden. So that's 17 plus 18. Let's see, that'd be 7 plus 8 is 5. 15, carry the 1. So 1 plus 1 plus 1 is 3. 35. I know I didn't really stack those. And by the way, we could, just from the commutative property or the associative property, at this time, add the 17 and 18 there, which gives us another 35. This is still going to be added, and now I'll add these two together. 5 plus 5 is 10, carry the 1. 1 plus 3 is 7. So that's 70. This would be 70 feet for the perimeter. Now, as fun as that was, we are not finished. That only gave us the perimeter. The real question here, if I can write this, the real question is asking how much money does she need to pay? Well, perimeter is a good stepping stone into finding how much money she needs to pay, but it's not the final answer because it says, like we've shown, each foot is $7. So that's like saying, in this case, that you have 70 groups of 7 right here. $7 for each one of these square feet, not square feet. And that then will give us the final cost in dollars here. So for me, I would look at this and I'd say, well, I see the 0 on the tail end of the 70, which means we're going to have a 0 at the tail end of our answer. And then I would just do 7 times 7, which is 49. So that ends up being $490 for Catherine on her garden project. Now, another quick relation to the order of operations stuff is you could have said, well, I'm going to add those 4 values together in purple that we had, length plus width plus length plus width, and then you could have added the 7 right there. Still an order of operations problem, but again, usually just almost by nature, we would say that we know we would have to find the perimeter here first and then multiply by 7. However you do it doesn't matter as long as you get the same answer is really the important thing. Although you really are using the order of operations, whatever method you're using. Lisa got 77, 58, and 45 on her 3 tests. What is her average in the 3 tests? So average is where we're going to take and I make it a fraction for me anyways. And for the numerator, we're going to find the sum of the values. And in the denominator, it's just the number. I say it's the number of numbers just because it's easy to write like this. But it's however many values you added in the sum. So the sum on this one, we're going to take those 3 values, 77, 58, and 45, and we're going to add those numbers together. So that's what part of finding the average. And then the number of numbers, how many numbers are there? 1, 2, 3 numbers. So whatever we get from this, we're going to divide by 3. Well, it looks like we're going to get kind of a big number, so we may need to use some long division. That's okay. So whatever we get out of this, I'll still show it as a fraction. It's not going to change the denominator, but by the order of operations, we should fully simplify the numerator right there. So that's 77 plus 58. I'll do that first. So 8 plus 7, 7 plus 8, either way, 15. Carry the 1. 1 plus 7 is 8, plus 5 is 13. Then we'll add the final score, 45. 5 plus 5 is 10. Carry the 1. 1 plus 3 plus 4 is 8. So we get 180 right here. So that's 180 divided by 3. I will show this with some long division, although perhaps not everyone would need it. And whatever we get out of this will be her average test score from these 3 tests. So what do we get? 3 will not go into 1. It will go into 18 6 times. 6 times 3 is 18. So when we subtract that, it zeroes out. If I drop this 0 from the 1's place value, 3 will go into 0, well, 0 times. So that quotient is 60. So it's an average score of 60. I'm trying to think of how to label this. Points, I guess. It didn't say it was percentages. So I'm just going to put points, I guess, on this one. It's an average. Eric bought 19 apples for $2 each and 17 pears for $3 each. How much money did he pay for all the fruits he bought? So take a minute, see if you can solve this one. We'll try this one out, and then we'll go over it as a class. All right? 1 minute, go. Got 19 apples for $2, and I'm just gonna start with the apples first. Okay, so I want to figure out just first how much was spent on the apples. Can I do that? Of course I can, and that's pretty much what the order of operations would do for us if we set it up as an expression, as a math expression. After we do this, then we'll do the pears. Okay, so the apples. There's 19 of these apples, and they're $2 each, so it's like 19 groups of 2. That's multiplication right there. When I multiply these, I'm just gonna skip the stack multiplication. You should get $38 there. And that's how much the apples would cost right there, 38 bucks. Well, we're going to take the cost of the pears as well, and we'll just add that to the cost of the apples. Well, the color set up pretty nicely for this one, by the way. It wasn't necessarily on purpose, but pears, looks like Eric's going to get 17 pears, and they're $3 each. When we multiply these out, I get 51 from that multiplication right there. The final cost here is just going to be the addition of these two, 38 plus 51. That would there give us the $89, which is what we thought it was. So that's going to be the cost for these. Looks like, what was that, 36 fruits? Terry had $36,777 in his life savings. In his will, he stated that after paying off legal fees, his life savings were to be equally shared amongst his 5 children. The legal fees after his death was $1,217. That should be dollars right there. Should be some kind of, we'll put the label ourselves, but it should be in dollars there. How much money did each child receive from Terry's will? So just by, again, this nice thing about these word problems when we look at the order of operations, they pretty much break this down for us, right? Because right here it says uh, the life savings will not be equally shared until you first thing we're gonna have to do, pay off the legal fees. Okay. So how much money was in the account? It just says up here. That's $36,777 right there. So what were the legal fees? It says that the legal fees were $1,217. So we're just gonna subtract these, and whatever we get out of this will be how much is left to distribute amongst the children. So we're going to subtract, starting in the ones place value. 7 minus 7 is 0. 7 minus 1 is 6. 7 minus 2 is 5. 6 minus 1 is 5. And then we'll just drop the 3. So it looks like there's $35,560 left over to distribute amongst the children. And it is going to be distributed equally, which indicates that we are looking at division. Division by 5, because there are 5 children. So I'm going to set this up with some long division here. So I will need a little extra space though. So $35,560. We're going to use some long division. Long divide by 5. So dividing by 5, I'd say, well, 5 does not go into 3, starting on the left there, but it will go into 35 7 times. 7 times 5 is 35. When I subtract that out, it zeroes out, so I'll drop the next value, the 5 in the hundreds place value. 5 goes into 5 once. 1 times 5 is 5, so we used up all 5 there. That zeroes out. How many times does 5 go into 6? 1 time. 1 times 5 is 5. When I subtract this, I get 1. I'll drop the 0 to make it 10. 5 goes into 10 2 times. 2 times 5 is 10. So that's going to zero out completely. So when I combine or divide the $35,560, we get $7,112 for each of the 5 children.